Stormwater sampling is an essential element of an illicit discharge detection and elimination program. Sampling requires careful planning and meticulous collection techniques. A well-designed sampling kit and protocol are necessary to achieve good results. This video describes the methods used by the Buzzards-based Stormwater Collaborative for stormwater sampling. Our recommended approach is based on the past 5 years of experience in collecting over 750 dry weather and wet weather stormwater samples from several municipalities. Sampling for indicators of illicit discharges usually begins at the discharge point. The sampling for the storm drain network is considered complete if water quality parameters are within EPA thresholds and no illicit connections are suspected. However, if there are indicators of a potential illicit connection, then additional sampling within the catchment may be required to identify the source. Additional samples can be acquired at various junctions to reflect a subsection of the catchment. In the example shown, the first sampling round at the discharge pipe evaluates the entire catchment. If the results suggest that there is a potential illicit connection, additional samples need to be collected, upgrading of the discharge pipe. A second sampling round is at the first junction and requires a sample from each of the 3 pipes that are associated with catchments B, C, and D. By sampling each pipe, the potential illicit connection can be isolated to a particular subcatchment. A third sampling round at the second junction could be used to further break down catchment D. A well-designed sampling kit is needed for an effective stormwater sampling program. The Buzzards-based Stormwater Collaborative sampling equipment and supplies fit in an 18-gallon tote. A cooler and blue ice are also required to keep samples secure and cool for delivery to a certified laboratory. The following short video provides a further explanation of the items to include in a stormwater sampling kit. For the sampling kit, a 16.5-gallon plastic tote is used. On the cover of the tote is a checklist for everything that should be inside. The first item is a sample work order binder. These binders typically have 7 to 11 sampling site sheets. These sites are grouped in accordance to the distance between each one and whether or not they need assistance from the DPW. Here's the kit's clipboard. Each clipboard is equipped with wet weather sampling data sheets as well as dry weather sampling sheets. These also have labeling stickers for the samples that are brought to a certified lab, as well as for the samples brought back to the lab or office to be tested by the stormwater sampling team. There is also a copy of the stormwater sampling guidelines located in the back of the clipboard, as well as a quick reference guide for creating the visit ID for each site on the back of the clipboard. This bag contains at least 10 of these smaller baggies. In each baggie, there is a sampling cup used to collect and transport the sample to a lab or office to be tested further by the sampling team. There is also a sterile sample cup, still in plastic, used to collect a sample and bring it to a certified lab for additional tests. This is a Ziploc bag with additional cups. These cups are used to collect a sample and test that sample on site. Next is this little caddy. In the caddy is the Hatch Pocket Pro Plus meter. There is also a wash bottle of deionized water, which is used to clean every piece of equipment between use. There is also a stopwatch to keep track of time while using the ammonia test strips. These are the ammonia test strips. They come with a small pre-marked and measured vial used during each test. Here is a tape measure. This is used to measure the diameter of the pipe being sampled. The caddies also are equipped with multiple pens and pencils to record data on the sampling sheets previously shown. Last in the caddy is a flashlight. This is just in case one might be needed. Here is a gallon bag filled with sand. This is used to fill smaller baggies and build dam-like structures on either side of a weak flow to create a more concentrated flow. This here is the hanometer, which is used to measure the levels of chlorine in the samples being collected. It is important to always make sure that there are enough of these free chlorine reagent packets for the anticipated number of sites to be visited that day. These are Kimtech task wipers and are used to remove any oil and dirt from the vial before testing. There is also a safety vest in case an outfall is in close proximity to the roadway. Here is a Ziploc bag with extra napkins and gloves just in case they are needed. There are also disinfectant wipes in all the kits to ensure clean work areas. Lastly is a trash bag in case there is extra trash that needs to be disposed of. Along with the tote is a cooler. Inside each cooler is an ice pack. This is used to protect the integrity of all the samples that are to be tested at later times that day. Lastly, there is a sampling pole. This is used to collect samples from outfalls located in difficult or potentially hazardous locations. An efficient and productive sampling strategy includes a travel plan to discharges in close proximity. Before sampling begins, discharges should be inventoried by recording exactly where they are located, photographing the pipe, and noting a future sampling strategy. The strategy might include which nearby structure to sample if the discharge pipe is not accessible, and whether participation by the local DPW is needed to access a structure. In the Buzzards Bay Stormwater Collaborative Sampling Program, an outfall record is created for each discharge that includes maps, photos, whether DPW assistance is required, sampling strategy, and even a safe place to park. These outfall records are grouped together to aid a sampling team to complete their work in a typical day. The next consideration is when to sample a discharge. There are two types of sampling events: during dry weather when there is flow, and during rainfall to assess stormwater quality. A dry weather visit to a discharge pipe that is not flowing should be recorded to show that the outfall did not have any flow. If the discharge is flowing during dry weather, the sampling team collects samples and other water quality data. Wet weather sampling requires adequate rainfall to create flows in the storm drain system. The tide level may determine when a pipe is accessible. During mid to high tide, a pipe may be submerged, but can be sampled during low tide. For tidal pipes, the salinity should be tested first to determine if the flow coming from the storm drain system is tidal water. Tidal flow does not give a true indication of water quality within the storm drain system and does not need to be sampled. The exact sampling location for any discharge pipe may vary. Detailed field notes and knowledge of the storm drain network are important to determine a sampling strategy. If location A at the discharge pipe is not accessible due to tides, location B at the next upstream manhole should be sampled instead. Always record where the sample is taken and the associated discharge that it represents. If location B is also not suitable, then proceed to sample at location C. Note that in this example, location C has 3 inlet pipes and requires the collection of 3 samples. Carefully record which pipe is associated with each sample. There is a standard list of water quality parameters and data collected at each site. These include some simple observations of flow characteristics, color, odor, and turbidity. This is followed by 6 field analyses of temperature, pH, conductivity, salinity, ammonia, and chlorine. These field analyses are performed with handheld meters or indicator strips. Additional water samples are collected to test for nitrates and surfactants, either back at the office or by a certified laboratory. The final standard test is for Enterococcus and must be determined by a certified laboratory. The MS4 permit may require additional water quality parameters to be tested. Additional water samples may need to be collected and brought to a certified laboratory for analysis if the receiving water body is listed as impaired. Additional parameters to be monitored are usually either total nitrogen in coastal waters or total phosphorus in freshwater. Once the sampling strategy for a storm drain network is defined, the sampling team goes out to the field to sample. The process begins with an evaluation of the site for hazards and the best approach to collect the sample. The Buzzards Bay NEP has assigned a unique facility ID number for all structures and outfalls. Determine and record the facility ID for the road cut, structure, or discharge pipe where the sample or samples will be collected. Make some basic observations and perform the 6 field analyses with the sampling kit tools and record data carefully. Then collect 2 100 milliliter sample cups, label, and store in a cooler for delivery to the lab. Other sample containers may be needed for additional parameters when warranted. Next is a field demonstration of sampling. Upon arrival at a sampling site, workers should put on protective latex gloves. Next, they should take a site sampling cup and remove the lid, breaking the protective seal. At this particular site, the outfall of the pipe was located at the bottom of a stone wall that separated the bay from the parking lot. A pole was needed to access the pipe and sample its discharge flow. In circumstances where a sampling pole is needed, the cup is placed in the cup holder at the end of the pole and secured with a clip to ensure it does not pop out once inserted in the water. After collecting the first sample in the site sampling cup, the salinity is measured using a Pocket Pro meter. If the salinity of the sample is above 5 ppt, the sampling process is not continued. The purpose of this project is to test stormwater, not ocean water. If the salinity of the sample reads lower than 5 ppt, the sampling process is continued. The next cup to collect the sample will be brought back to an office or lab where it will be tested further for nitrates and surfactants. This cup is also inserted into the sample pole and lowered to the outfall to collect. The last cup to collect the sample will be brought to a certified lab where it will be tested for Enterococcus and any further specified components. Once both samples are collected, they are labeled with their respected stickers, specifying what is to be tested and which location to be brought to. They are immediately placed in a cooler so as not to compromise the integrity of the sample. The sample collected in the site sampling cup is then used for further testing on site. The first test to be conducted is for chlorine. The sample is added to its vial and inserted in the manometer to be used as the control. It is then taken out of the meter and the chlorine reagent is added. After shaking it for 20 seconds and wiping the vial for dirt and oil, it is put back in the Hannah checker. After 1 minute, the results for the chlorine amount are displayed. The results for this test, along with other tests, are recorded on a water quality sampling sheet. The next test to be completed is for ammonia. The sample is added to the provided vial and filled to the marked line. A test strip is then vigorously dipped up and down with the pads always remaining below the sample level for 30 seconds. It is then held level with the padded side up. After 30 seconds, the test strip is turned around so the padded side is facing away. The color of the small pad is then compared to the colors on the color chart. Again, as the tests are being done, the results should always be recorded on the water quality sampling sheet. The last two readings will be completed with the Pocket Pro Plus meter. These readings include pH and conductivity. The rest of the fields on the water quality sheet are filled in, including the location sketch, station sketch, departure time, and so on. Once the sheet is fully completed, the equipment needs to be cleaned with deionized water. The meter sensor, along with its cap, is sprayed. The site sample can be disposed of and the cup sprayed with DI water. This cup can be used again at the following sampling sites for the duration of the day. All the equipment is then packed back into the tote and moved to the next sampling site. The sampling process is now complete. Sampling data can be recorded on a paper form or digitally with a tablet. The Buzzards-based Stormwater Collaborative uses paper forms because paper forms allows for easier sketching and perform better in the rain. This method requires entering data into a computer and allows for error checking. A tablet may be more real-time, but it is difficult to use in the rain and does not have the same level of verification or the reliability of a paper form. Detailed record keeping in the field is imperative for a successful sampling program. Situational awareness and notes of unusual conditions should be recorded. For example, if dead wildlife is observed in the outfall area, it may impact bacteria results and should be noted. Indicate whether a sample was collected from a free-flowing pipe or the sump of a structure. If samples are collected from multiple inlet pipes in a single structure, create a sketch to document where samples are collected. The Buzzards-based Stormwater Collaborative has adopted the convention of labeling pipes clockwise from the outlet pipe as A, B, C, and so on. The letter S is used for sump samples when a pipe is submerged. All this information and the sketch is included on the data form and is needed when evaluating the source of a potential illicit discharge. After sampling is completed for the day, the samples for Enterococcus and other MS4 required parameters must be delivered to the certified laboratory within 6 hours, followed by the last step of in-office testing for nitrates and surfactants. The samples must be kept cool and the test completed within 24 hours of collecting. This brings us to the end of this video. Note that the tasks demonstrated in this video are services offered by the Massachusetts Maritime Academy to local communities. We hope you found this helpful and check back on the Buzzards-based Stormwater Collaborative YouTube channel for more upcoming features.